Hi, everybody. Welcome. Thank you for joining us for today's webinar. My name is Jenny Novak, and I'm the Marketing Manager, and I coordinate the webinars here at Dine Fire Protection Labs. Welcome back if you've joined us before. If you're new, thanks for tuning in today. We're coming to you from Minnesota, which has had a little bit of a warm-up lately. I think yesterday was 60, almost 70 degrees. Today we heard a little lightning and thunder, so that was kind of unusual for our March. But I'm hoping the rest of the country is also in a warm-up. Just a quick intro about us. Dine's an independent testing laboratory. We've been doing firefighting foam testing for about 20 years now. We also test dry chemical agent, antifreeze, and we do offer total PFAS analysis. We've been testing sprinklers since the end of 2016, which we'll be talking about today. You'll see some of our kits behind me, our standard and dry kits. Dine is a ISO IEC 17025 accredited by A2LA for our automatic sprinkler testing, as well as ISO certified for 9001 and 2015 certified. Just a little bit of housekeeping before we get started today. I usually go through this. If you have any questions during the presentation, feel free to use our Q&A panel window. Some of you guys will see a chat. You can also type them in there. We'll catch your questions, and we'll save them up till the end and have a Q&A session. If you're looking for that panel, you can get to it on your control panel. If you hover, there should be a bar with 3 dots in it, and you can get to the Q&A session there. Today's webinar, Sprinkler Field Service Testing, will be presented by Grant Lobdell. He's our General Manager here at Dine. He has an extensive knowledge of firefighting foam, sprinklers, dry chemical agent testing, and antifreeze, as well as NFPA 25 requirements. If you'd like to stay till the end of the webinar to receive a certificate of attendance, some people do use our webinars for NICET credits. I know some of you out there are NICET certified. This webinar is being recorded, and you'll also receive a link to our unlisted video published on our Dine YouTube channel. Feel free to subscribe to that if you don't already. Now I'd like to turn it over to Grant to talk to us about sprinkler testing.
Thanks, Jenny. So we'll get right into it. As she said, Grant Lobdell, General Manager here at Dine Fire Protection Labs. Oh, I've been here probably 8 years now. Participate in various NFPA committees, the NFPA Sprinkler Research Council. Many of you maybe have seen me on these webinars before. Maybe we've chatted if you're a customer of ours, or so I should be pretty familiar to some of you. As you signed up, you've seen the objectives. Really, this webinar is going to be geared toward contractors that are involved in the ITM, the inspection, testing, and maintenance of sprinkler systems. Specifically today, we're going to be talking about the field sprinkler test. Kind of when is it due, how many do I need to send in, what am I testing, what does the testing look like, what do I get back? So kind of a little bit of broad, just overview of the whole field service test. As Jenny mentioned, there'll certainly be a Q&A. You can type those in at any time. I won't stop my presentation to answer those until the very end, but feel free at any point to put them in there. There'll also be some videos and obviously some pictures for you guys to look at. Before I get going, so I will be referring to NFPA 25, and I'm going to refer to my 2020 edition. That is the current one right now. I realize many states are behind, depends which state you're at, which one is adopted currently. But whenever I talk about NFPA 25, I am going to be referring to the current 2020 edition. The next edition is actually in draft 2 currently, so they are already well underway on the second edition, or the second draft of the next edition. There'll be a few times I'll kind of comment on, hey, this might be coming up in the next edition as well. But before I get going, I always do this disclaimer. This webinar shall not be considered the official position of NFPA or any of its committees, and shall not be considered to be nor relied upon as a formal interpretation. So this is my opinion of it. If you would like a formal interpretation, you can certainly go to nfpa.org and request one. So now that we got that out of the way, let's jump right in. So starting off with a pretty obvious statement that sprinkler performance will degrade over time. We're taking a metal object or a device and putting it out in the elements. It's going to degrade over time. How fast it degrades is obviously going to depend on a couple factors, and I've highlighted here obviously the environment. If I'm in an environment, maybe it's highly, there's a high moisture content in the environment, or harsh chemical vapors, cleaning agents, things like that. Something that'll accelerate the corrosion, well, that's going to obviously, it's going to degrade quicker. Temperature too, a lot of people sometimes forget about that. We always remember corrosive, harsh environments, but high heat, if you exceed the maximum ceiling temperature rated for each sprinkler, that's going to degrade it as well. specifically the solder sprinklers. So what can happen is maybe my sprinkler, looking at the chart here on screen, I've listed the maximum ceiling temperatures based on the rating. Let's say I have a 155 degree Fahrenheit sprinkler. That's my rating. Well, the maximum ceiling temperature on that is 100 degrees. So what we're saying is, yes, it's not going to activate. You put a brand new sprinkler up, and it's not going to activate till 155. But as soon as you start getting over 100, you're gonna kind of soften up that solder, and it can migrate. We call it solder migration, where it can kind of shift a little bit. Yes, if it cools back down, that solder will reharden. The sprinkler never went off, you know, but what you don't realize is when it softened and rehardened and migrated a little bit, shifted, you've actually weakened that link a little bit. So the next time it heats up, before it was 155 activation, maybe now it's 152, maybe it's 150. So it can be detrimental to the performance if we start exceeding these maximum ceiling temperatures with solder type sprinklers. So that's something to consider too. Obviously, along with the environment, how quickly these sprinklers are going to degrade, sprinkler design has been shown in the past to be a big factor. And specifically, I'm talking about those O-ring water seal recalls. That was a design that clearly did not work well and led to sprinkler failures much sooner than hoped. All right, but we can go the opposite direction as well. Let's say I am in a harsh corrosive environment and my sprinkler is going to degrade quicker. There are designs, there are corrosion-resistant materials and coatings you can purchase on your sprinkler to increase its lifespan in such environments. So we can go either direction on this. So it's pretty obvious. I mean, sprinklers at some point are going to need to be replaced. Again, we're taking a metal object, putting it out in the elements. No matter what we got a car, we got a high-rise building. At some point, it's going to fail. At some point, it's going to degrade. So NFPA has outlined in NFPA 25 when that replacement is to occur. All right, and really it breaks down what I like to think of it as is we're first going to identify, well, is my environment considered harsh or not? And I get a lot of questions all the time about, well, what is a harsh environment? In the back, in the annex, so the explanatory material, not in the actual code, enforceable code itself, but in the explanatory material, they list several environments. We have paper mills, packing houses, tanneries, alkali plants. They list several examples, but that's not all inclusive. I mean, anywhere where I could have corrosive vapors could be a problem. We've had this argument at the committee meetings before. Water's corrosive. I mean, I get water vapors, that's corrosive. I think ultimately what it comes down to is if I'm outside, my typical, what I could expect for humidity, Minnesota here right now in the cold winter, we don't have that humid, but in the summers we can get up there. Once we start exceeding, if we're talking like an environment where maybe I got a swimming pool or something like that, that's probably a corrosive environment. But you know how you can be sure is you contact the manufacturer of the sprinkler. Tell them what you got, here's what I got. They're going to look at the material it's made of, and they should be able to tell you, hey, is this, you know, do I think I have a corrosive environment or not? So we're going to identify first, is it corrosive or environment or is it not? If it is a harsh environment or a corrosive environment, and it's not, if your sprinkler does not feature a listed corrosion inhibitor or, a listed corrosion resistant coating or material, you're going to have to replace those every 5 years. So that's very detrimental on the performance of that environment, and the sprinkler is not rated to handle that. So every 5 years. Obviously, if you have a listing, you have a corrosion-resistant sprinkler, they've allowed it to extend it double the lifespan, every 10 years for something like that. So if you're in a harsh environment, you're expected every 5 or 10, depending on the type of listing you have with that sprinkler to replace. If it's not a harsh environment, like I'm in a conference room right now in our office, even our laboratory, all the vapors are contained in our fume hood. It's not harsh there. Even our warehouse is relatively mild. There's no harsh environments going on here. Well, then I got a different set of parameters. So dry sprinklers, we're going to replace after 15 years. So this is new in the 2020 edition. So many of you, if you're previous editions, it probably says 10 years. For a long time, we were at 10 years. This is one of the things I'll mention in the next edition, and we'll get into why this is later when I talk about failure rates. They're even considering maybe pushing this further up to 20 years where we have to replace. They're extending it. Fast response sprinklers, so this includes ESFR. We're talking 20 years after install. And any other sprinkler, so your standard response sprinklers, we're talking 50 years after install. And I often get the question, well, why are there such different times? Well, standard response sprinklers, 50 years, those have been around a fairly long time. We have lots and lots of data to suggest it can go 50 years before needing replacement. Fast response sprinklers are a little bit newer technology. Okay, we don't have 50 to 100 years of data sitting there to look at, all right? So they went down on that to begin. If the data continues to suggest that, hey, you can go longer than 20 years, we're not seeing many failures after 20 years, I expect that one will increase too. Same thing with dry sprinklers. The dry sprinklers was a unique one because of the O-ring, I guess you could call it issue, debacle, whatever you want to call it. The failure rate with those O-rings, which were prevalent in dry sprinklers for a spell there, was a big factor in this. There's a lot of O-ring dry sprinklers out there that needed to be replaced, and they weren't working even after 10 years. But now it's been over 15 years, maybe we're getting close to 20 years now, that an O-ring sprinkler has been listed at UL. So most of those are out of there by now. So what we got going on is, okay, the O-rings are no longer in service, so we can extend that rate, all right? So we're at 15 years, maybe we go to 20, we'll see where it ends up. But those are our replacement intervals right now. Corrosive, 5 or 10, depending on what's listed. And then depending if it's dry, fast, or standard, we got 15, 20, or 50 years. So I've talked a lot about replacement, and many of you are probably thinking, boy, that's going to get costly, and that's what NFPA is thinking too. We got to replace these all the time. Well, for good news, in lieu of replacement, you can test instead, all right? And this is what many people choose to do. It can help keep potential replacement costs low, and what we're going to do is we're going to confirm, okay, this sprinkler is still maintaining its performance and hasn't degraded to an unacceptable level and can remain in service, all right? But realize we're going to have subsequent testing after that. So come 50 years, let's say the picture shown is a standard response sprinkler. 50 years, it comes time to replace, you're like, you know what, I'm going to test instead of replace. Testing shows, yep, this sprinkler is still performing just fine, can remain in service. But it doesn't mean you get to go another 50 years. If you test it, okay, in this case, it could be 10 years. If I have a harsh environment, it's going to be every 5 years. Then I'm going to keep testing it every 10 or every 5 years to make sure it continues to maintain it. At some point, it's gonna fail, and that's when it would trigger, okay, now I need to replace them all. So when it comes time for sampling for testing, and this is kind of a misconception we run into a few times, is we're not testing every sprinkler in your building, your area, your floor, whatever it is. We're not testing every single sprinkler. As soon as you remove that sprinkler from service, you're not allowed to put it back in service. Once you unscrew it, you can't put it back up, even if I gave it to you back. 2, the testing I do is destructive. So when I go and I test this and I ensure, yep, it released at this time, I can't reassemble it. The solder is melted, the glass is broken, whatever we got going on, it's a destructive test. So what you're actually sampling when it comes time to testing is just 4 or 1% at least, whichever is greater. So in a building like this, I have less than probably 100 sprinklers. Okay, I'm going to have to send in 4. 1% is only 1 out of 100. So 4 is my minimum. I'm going to send at least 4. But realize I've been saying at least 4 or minimum of 4 or 1%, whichever is greater. You may have to send more. All right, we want to make sure every sprinkler in my area is represented. If my building, when it was built, we put in the same sprinkler throughout the warehouse, everywhere, it's the exact same sprinkler, okay, yeah, 4 or 1%, choose them randomly, send them in for testing. But let's say maybe I did an addition at some point, and I have a different sprinkler there, or maybe I chose this temperature rating here, but maybe in my laboratory I have a different manufacturer or temperature rating, things of that nature. I'm going to want to make sure I at least get one of those in there to represent it. Even different environments. If I were to sample my building here and I've told you I have an office area and a warehouse, I probably want to take one from the warehouse and one from the office in my sample, simply because they're different environments. They may have interacted with the sprinkler differently. The warehouse, fairly conditioned, not as nice as the office, but it's a different condition out there. Maybe one would fail out there. All right. Now realize when I'm talking about different sprinklers, okay, what I've shown on screen here, these are actually from a warehouse. It looks like 3 different sprinklers. I mean, technically they are different, especially these 2. The middle one is a sidewall, and the left one here I have an upright. Both of them feature a pellet. They appear to be the same manufacturer and everything else. The only difference here is the deflector. And NFPA puts in the annex that you can consider just if there's only a difference in the deflector, the orientation, those are the same sprinkler regarding this testing, all right? So we'll get into it later, but the field service test, I'm not testing the water distribution pattern. That deflector has no bearing on the testing I'm doing and what I'm evaluating. So in this instance, what I'm evaluating is just the release mechanism, which is they both are the same manufacturer, the same pellet, the same temperature rating. To me, these are the same sprinkler in terms of the field service test. But the one on the right here, which features a fusible link, looks like one of those Grinnells, that would be considered a different sprinkler. So I'd want to make sure I get that one on the right, and one of these, they could be considered the same as well in my sample. If I'm going to send all four, maybe you choose to even grab the sidewall. But that deflector, the orientation makes no difference on the testing I'm doing. Obviously in the listing, it's definitely getting tested, but in the field service, the periodical follow-up, that does not get evaluated. So I'm going to send in 4 or 1%, could be more. I want to make sure I get everything represented in my sample. And 4 or 1% of what? Am I doing that by system, you know, am I by riser, by floor, by building, by room? NFPA 25 does not tell you what your sample area needs to be, and this is on purpose. They want the building owner or the designated representative, if you're a contractor out there listening, yourself, to define this. What is your sample area going to be? Again, just referencing the building I'm in here, I have an office and a warehouse, maybe 100 sprinklers. I certainly can say, yep, I'm going to consider this all one big sample area. I'll take 2 for my office area, maybe 2 for my warehouse, and then that's going to be my 4 or 1%, assuming everything, I only have a couple different types of sprinklers in my area. Or I could consider the office one sample area by itself, send 4 from here, and I can take my warehouse and send 4 from there. Now, why would you do that? Well, the reason you want to break up these sample areas at times is you can have one failure, even just one, and you're expected to replace every sprinkler that that sample area represents. So again, take my warehouse. Let's say it's more likely to fail just being a warehouse, not as conditioned as the office. If I sampled my whole building here at Dine and sent in 4 and it represented, I took 2 from the warehouse, 2 from my office, sent them in. I had one failure out in the warehouse. Now I have to replace everything at Dine, all right, because I consider that my one sample. But had I sent 4 from the office, 4 from the warehouse, and again, still that same sprinkler from the warehouse that I grabbed failed. It's a different environment. It failed, more likely to fail out there. Well, now I just have to replace the warehouse, right? Because I sent that, okay, I sent in my requirement of 4 or 1%, whichever's greater, from my warehouse, but that's my sample area. That's where I had my failure. That's what I replaced, not the entire thing. So that can be very beneficial in some regards. Let me go back a slide here. If I'm in this high rise here, and let's say I have one failure on the 30th floor, but I considered the whole building the sample area, and I have one fail on the 30th floor. Maybe there's something odd about, maybe they did some fumigation or some cleaning or something on the 30th floor where some harsh vapors interacted with the sprinkler. If I have one failed and I consider that whole high-rise building one area, well, now I have to replace everything, all right, in that whole high-rise. But had I done it by floor and just one failed in the 30th, well, now I just have to replace the 30th floor. Obviously, it's going to be a breakdown, a cost benefit. Okay, well, I have to send in 4 from every floor. Okay, that's a lot to send in for testing. Well, is it worth it? You got to see how many are on the floor. How many would I have to send in versus how many would I potentially have to replace? So like I said, NFPA 25 does not define the sample area for you. I'm not here to tell you, yeah, you should do it by system. You should do it by floor. That is up to the building owner, or if you are their designated representative, up to yourself in that regard. So definitely it's very important that you define it. However you define it is up to you, but it does need to be defined. So when it comes time, let's say the building owner or the contractor, the designated representative, has decided, okay, I got a lot of sprinklers here. I don't want to replace every single one. That cost is a lot. I'd rather just send in 4 or 1%. That seems more reasonable. And they've decided, yeah, I'm probably going to break out my warehouse and I'm going to break out my office into 2 sample areas. Okay, they've gotten that far. But now comes time to actually take down samples to test. You've realized, okay, I got 2 different types. I want to get 2 of each of those. Now, where do I take them? It should be random, all right? It shouldn't be just because, well, I don't have the ones by the front door, you know, I don't have to go in very far. I can get a ladder easily in there. I'll just take those ones. It really shouldn't be. It should be at random. Obviously, if you have different environments, like I said, you want to make sure you get those representative. So if you took Dine and I represented it all as one area, including the warehouse, I can't just take 4 from the office and call it good. If my warehouse is a different environment and it's in my sample, I should get at least a 1 in there in that sample. All right, so we want to make sure everything's representative. So again, we're choosing them at random. And we should before we're testing. So I'm going to come in, okay, they want me to test. We've decided this is my area, I'm going to test. Before I actually take down those sprinklers, I'm going to do that annual floor level inspection that I do. All right, I'm going to do that before I consider anything for testing. So I'm going to replace anything that has leakage, corrosion detrimental to performance, physical damage, loss of fluid in the glass bulb, loading that's detrimental, or paint other than that applied by the manufacturer. I'm going to go through pictures of each of these and why it's important. But I'm going to go through and replace any of those, and what's left, that's what I'm going to sample from. So let's go into a little bit just of this floor level inspection and what I should replace. I shouldn't even consider these for testing. So leakage, that was one of them. So again, we're going to have water damage with leakage. You know, if you're unfortunate enough to come to a puddle or water streaming out, obviously that's leakage. But a lot of times, leakage will just be represented by corrosion around the water seal. So this would be, you know, this upright sprinkler here. You can see a lot of corrosion around that water seal area. So what's happening there is water is just slowly leaking out and probably evaporating before, you know, there's no puddle on the floor before you even notice. But that water getting on there, so I have a high moisture content, I have oxygen in the air, and I have metal, I'm getting corrosion. So a lot of times we'll see issues like this. If it was a pendant sprinkler, a lot of times I might also even see if there is some water that's seeping down, I might see some corrosion building up around the deflector there. So if I have very isolated corrosion like this could be an instance where I have leakage. Again, why does it leak around there? A lot of people are quick to, oh, the manufacturer didn't seal it correctly. From my experience, that's pretty rare. Typically when these leak, it's usually just over tightening. So a lot of these sprinklers, you know, when you get a data sheet for them, they should have a torque rating on them, and that's as much as torque you should put on it. And I'll have a damage picture for you later showing when we over torque them. But so leakage, I see anything with leakage, I'm not even going to consider that for testing. Given this corrosion here, it would probably fail. But that clearly fails the visual inspection, I'd replace. So both corrosion and loading, two other things you're looking for in your visual inspection, they use the verb or the term detrimental to performance. So we're allowing some corrosion and some loading, and we're only replacing when it gets to be detrimental. That can be a judgment call, and I've definitely had a lot of questions about, well, what is detrimental, what's not? Our website, I would refer you to there, has a lot of, we have pictures with, okay, here was this sprinkler, here it had this corrosion, this was the response time, did it pass or fail? We have a lot of examples out there, but even then, there is still somewhat of a judgment call. But why is corrosion detrimental, or when it's detrimental, why is it important we replace that? Well, obviously, corroded parts, a lot of times they can, well, one, they could weaken, or they can fuse together. That's typically what we see. The most common cause for a sprinkler failure, by far, is corrosion around that water seal, where the release mechanism may still activate, but the water seal is stuck on there. The corrosion is just holding it in place. Physical damage, obviously, if you see that, sprinklers like this, I think all these images I'm showing are ones we have received at the lab. We will test them, no matter what you send us, the condition, with one exception I'll get into here. We will test them and give you a result, but stuff like this, you know, it's going to fail if we can even test it, when really you could have just replaced it ahead of time. If that was the only one that looked like that, replaced it and sampled the rest. But getting back to physical damage, obviously physical damage could impact the sprinkler performance. What's shown on screen obviously is an extreme example of over-tightening a sprinkler. I'm assuming this is during removal, simply because if I would have had such a oval opening with a round water seal, I would have had water leaking everywhere. So I would assume these were just sent to us as pictured, which obviously this is the one exception. We can't test if I can't hold the pressure. So if I can't test this, and two, there's nothing to test. We'll get into what I actually test, but there's no release mech, there's no water seal. So stuff like this, we should not be receiving. Physical damage, we should be replacing. Beyond just physical damage to the water seal and frame here, this one actually also has a little bit of a bent deflector. Maybe someone hit it with a forklift or something, but we're not going to get the water spray pattern, the distribution pattern we should. I'm not going to get water where I need it to be, where it's designed to be. So that's something I should be replacing too. Loss of fluid in the glass bulb, if you see this, again, we're not considering it for testing, hopefully, we are just replacing. So the sprinkler shown here, you can see it is clear. It looks like there's no liquid in the bulb, but be very careful. There's instances, especially in direct sunlight, if I have a lot of UV light, or if I'm in a freezer, there are instances where glass bulb sprinklers, the color, the dye inside them, can come out of solution, can change. I can get a translucent looking bulb. Those ones in the freezer, usually if I take them out of the freezer and were to allow them to heat back up, okay, the color comes back. They've shown that it's not detrimental to performance, just a loss of color, but obviously the loss of fluid is. How can you tell? Well, a lot of these, or all these bulbs, they have a little air bubble, kind of like a level. You know, you put a level on something, you've seen that air bubble move. If you can see the air bubble in it, well, you got the liquid. You could compare it to other ones as well. If you're, well, that air bubble looks a lot bigger than the others. Well, maybe you have lost some liquid, just not all of it yet. But the joke is with these, the loss of fluid in the bulb, will it go off? You know, okay, like this one here we received at the laboratory. Well, can you still test it? Well, I can, and it will go off, but not until the melting point of glass, if your fire ever gets that hot, because there's nothing in there to expand. The liquid, you know, that's how a liquid bulb works. The liquid expands, pushes on the glass at a point, it breaks. So it expands into that little bubble that we were talking about until there's no bubble left, and then it just bursts. In this case, I don't have any liquid. Until that glass melts, that water seal is not coming out of there. So if I ever see any loss of fluid, I'm going to replace that. And if I see any detrimental loading, I'm going to replace that. So on screen, I have two different examples of loading. On the left here, looks like a lot of dust. I've seen something very similar in a veterinary office near me. Something like this, will it go off? It probably will, but much later than what's allowed. All right, it's going to take longer to go off. So the heat is going to take a while to get through all that debris, and it's got more mass to heat up. It's got to get through that. It's insulating, essentially, that debris shown on screen of that loading is insulating that release mechanism. It's going to take longer to go off. The example on the right is loading on just on the deflector. Is that detrimental? Well, yes. I mean, I'm not going to get my distribution pattern. Obviously, this is an extreme example, but I'm not going to get the water where I need it to be. So this is another example where this loading is detrimental. This one on the right, I think there's actually a bee or a hornet or something when we received it inside of it. So again, we shouldn't be receiving things like this. We should be replacing before we send it off to lab. And I did want to note, okay, I do have, let's say this here, I got some loading I'm showing on screen on the picture now. Do I need to replace this? Is that loading going to insulate it? Looking at it, you know, myself, and again, you can reference pictures, I don't think that'll be detrimental. It seems like a very small amount. The heat, if you could look at it, considerable to get to the release mechanism. The deflector is a little concerning. It looks like it's kind of built up on there. I might not get it. So do I need to replace this one? Well, you can. In lieu of replacement, you can actually use the compressed air or a vacuum and clean that off, provided you don't touch any part of the sprinkler. All right, they're worried about damage. They're worried about someone getting in there and poking out that that glass bulb, especially, you know, those are really delicate. So they're worried about if someone touches it, they might break it. But if you have a vacuum or compressed air, you are allowed to clean them off. Something like this, compressed air would probably clean right up. I have been asked a couple times with compressed air specifically, being worried about, well, compressed air can be quite cool, it can be cold. Is that going to be an issue? Am I going to, you know, kind of freeze my bulb and it's going to break? And I guess take some, you know, understand the UL listing. They do test these bulbs at pretty cold and pretty, you know, going to get, obviously they get it to activation temperature. They're doing these temperature cycling tests. And when I look up UL 199, the standard UL Underwriters Laboratory would use to list these sprinklers, they can get even down to negative 40 degrees Fahrenheit or Celsius. It's the same at that temperature. So negative 40 is pretty far. I don't think your compressed air is getting it that cold. But they've done testing to show when they list it, okay, if it's listed, it's been evaluated, they've tested it down to negative 40, and it hasn't broke on them. So take some peace in knowing that there was testing done at very cold temperatures. So we shouldn't be too concerned about the degree of the compressed air. But still be very careful if you are choosing to go that route, that we don't damage the sprinkler. We don't want any water damage. And non-manufacturer plaint. So we're still talking about all the visual inspections, the floor level visual inspections. I'm not taking binoculars out. I'm on the floor just looking at it. I'm going to do any non-manufacturer applied paint I'm going to replace. So again, what's shown on screen is a sprinkler we've received. Probably was a good candidate for replacement instead of testing. This failed. Why did it fail? It didn't release. It tried to. You can see a little bit of separation at the top here, but at the bottom I have paint holding that link together. So this was a fusible link. I had solder holding two metal pieces together. The way it's designed, when it gets to temperature, that solder melts at a specific temperature. Those links are able to release. and then everything is able to, the water pressure underneath will push everything out, and it'll activate and clear. But in this case, the paint, which didn't look like much, we have a little bit on the arms, and we have a little bit here on the release mech. The paint's holding it together and actually caused a failure. So we got this in the lab, we tested, it didn't release, it fails. Now everything in the area has to be replaced. Had they seen, maybe this is the only one that looked like this. Had they just replaced it, not sent it, then they wouldn't be in this situation. But we want to make sure we look for that and get them replaced. So we've gone through, we've decided we are going to test instead of replace. We've gone through the math and figured out, yeah, you know, we got a lot of sprinklers here. Testing is an option. Even though I got to test every 10 years, it's still going to cost, just testing 4 is going to cost me a lot less than replacing everything. I've defined my area, and then I've gone through, done my visual inspection, replaced everything that failed the visual inspection. I pulled my random 4, 1%, whichever is greater, maybe more if I have different types. I want them all represented in the area. So I got them all down. Now I'm going to send them to the lab. Worst thing you can do is just literally just plop them in a box, a random box, and send them off, right? So especially if I have a glass bulb sprinklers, they might rattle around, they might break. I want to make sure I get them packaged so they're not getting damaged on the way to lab. I told you before, no matter what you send us in condition, we'll test, except for one thing, the damage, right? If the release mech is already activated, or I can't hold the pressure, the water seal is a little, you know, it got dislodged, I can't test it. So we're going to make sure we take care to make sure we get them to the lab in good condition, or the condition you found them in, right? We don't want to be manipulating them, cleaning them, anything like that. So we do offer a free standard kit on the left. I'd certainly take advantage of that. Obviously, you can see the padding, the amount of effort we go to make sure we receive the sprinklers in the same condition you took them down in. We fit comfortably 4 in there, typically, is what we suggest. Again, free shipping within the contiguous United States. It's a free standard kit. We'll give it to free, and the shipping is to you and back. It's a heck of a deal, all right? Take advantage of it if you're in the U.S. This kit on the right is a dry sprinkler kit. So obviously dry sprinklers can range anywhere from a couple inches to, I think, 4 or 5 feet now, depending on how cold it is. You know, you need a longer barrel, a dry barrel. We have telescoping boxes available that you can actually, okay, it's gonna slide out or in depending on the size you need, a couple different sizes. Unfortunately, due to the size and the weight and the shipping costs of these, there is a small fee for those kits. For the dry sprinkler kits, you know, instead of paying that fee, I often suggest, okay, when you take the sprinkler down, remember that you're not getting that back. And once you took it down, you can't put it back in. You got to put a new sprinkler in its place. Well, the new dry sprinkler came in a box. Just reuse that one. Put that one in, slap a label on it, ship it off to laboratory, ship it off to Dyne. So those are the sprinkler kits available. We're going to take care not only to make sure they're in good condition, we're also going to take care to make sure we label them really accurately. So I talked about how important it is that, okay, I label my sample areas, because if one fails, I have to replace it. Well, if you just ship me a box of 20 sprinklers without labeled, it's from this area, well, you're not going to know when one fails, well, which sprinkler did that, what area did that represent? So it's very important you make sure you label them. Well, where was it from, and how are you defining your sample area? So that's going to be important when it comes time, and the AHJ is wondering, okay, you had a failure, what did that represent? Well, you got to make sure you know, right? So we sent them off to the lab. That's about where we are in our process here. Now comes time for us, for Dyne or for the laboratory you choose, to do the field service test. So it's going to be done, the NFPA verbiage is recognized testing laboratory acceptable to the authority having jurisdiction. If you ever get any pushback on well, are you acceptable? We do have several documents available you can request. Big one typically is the ISO certification. We're 17025 accredited, for 17025 for our sprinkler test. So what we're going to do when we go into laboratory testing it is we're going to use what's shown on screen, which is our plunge test oven. Manufacturers would have something like this, laboratories. So essentially what we have on the left is a bunch of heaters, and then the flow of it's going to pump air with a fan, it's going to flow air with a fan, and the picture shown in a clockwise direction around the oven. So simple by design, but to insulate it to the degree that we're keeping it very accurate temperature, even at the high temperatures, and we're keeping the flow very constant. It can get quite costly to design an instrument like this. So we're going to use this plunge test oven to take your sprinkler and expose it to a specific temperature, specific airflow, and pressure. So I have a video here I'm going to actually pull up and show you. It's a little bit dated video, but it's a good one of the test here. So again, same oven I showed you before here at Dyne. This is myself, a younger me, a thinner me, putting a sprinkler into the oven. So right there, I'm connecting air pressure to it. The sprinkler is on that test plate I assembled onto the oven, and I will plunge it. As soon as I plunge it in, there's a device on the back of the oven that sensed, okay, the sprinkler has been plunged in, and it starts a timer on my instrument. This is just a different angle of the sprinkler going into the oven. So in this shot, I'm looking down the oven, so the air would be coming toward you when you're watching this video. So the sprinkler is in there. It's getting right now exposed to a specific temperature and heat, and the glass bulb explodes. The liquid expands. It went. You could even see the water seal fall out there. That was just slow motion. And I think I just pull it out and show it to the camera that, yep, it fully, it activated and the water wave fully cleared here. So that would have been under 7 PSI of pressure, and we'll get into that in a moment. But so that's it. I mean, that's the field service test. Obviously, dry sprinklers would require a little bit on our end to get them into the oven. The barrel usually sticks out. We have a plate to accomplish that, but it's simply assembling it to the plate, putting it under pressure, exposing it to this. This was probably 135, if that was a red bulb, 135 Celsius in this oven right now, probably 2.5 meter per second airflow, and again, 7 PSI pressure. So gets in. This was a quick response bulb, I believe. Yep, looks pretty thin. So it only takes a few seconds to go off. Standard can take a little bit longer, but that is what the field service test looks like here at the laboratory, and that's the instrument we use to determine. So when we do the field service test, what are we actually evaluating is the sensitivity and functionality of a sprinkler, which is kind of a loaded statement, but we'll break it down into first the sensitivity. That's the release mechanism. So the glass bulb, the solder, the pellet, what exactly is the temperature doing, what's going to release the sprinkler? Now, if I took a sprinkler and I told you, well, it went off in 10 seconds, that doesn't tell you the whole story, all right? Just the time by itself. Well, okay. How cold was it when it started? How hot of an environment did you put it in? What kind of airflow was passing by it? Was it really slow, fast? There's a lot of variables when you say, well, this one takes 10 seconds to go off. There's a lot to know. So we typically don't talk about in requirements, we don't say this sprinkler has to go off in 10 seconds. What we'll say is this sprinkler has to have an RTI below a certain value. And I'll get into that in a moment, but what am I talking about when I talk about RTI? So I told you response time is definitely part of it. But so is the temperature that the sprinkler is before I put it in the oven. The temperature of the oven, okay, I took a 20-degree sprinkler and I plunged it in a 135-degree Celsius oven. I need to know those variables. I need to know how fast I'm flowing that air. We take all of that stuff, all those variables, and we plug it into this equation, and that's how we get our RTI value. So what this does is it kind of levels the playing field. So if a laboratory starts out with a sprinkler at 20, but another one starts at 25, that's accounted for in here. They should get the same RTI. If a laboratory plunges the sprinkler in an oven that's 135 and another at 150, well, it'll go off faster than the 150, but it should have the same RTI because that's accounted for in this. So we're spitting all those variables into this and getting out an RTI. Now, what are our RTI requirements? So I'm saying we're not going to say this sprinkler needs to go off in 10 seconds. What I would say is an ESFR, an early suppression fast response sprinkler, needs to go off, has an RTI of 50 for the field service test. Fast response is 65, and your standard response are allowed to go up to 350. Coated sprinklers, wax-coated sprinklers do have kind of an exception. They can go a little bit higher sometimes, but that would be my requirements. That's what's called out in NFPA 25 specifically, and that's how we'll define it. Now, on a test report from us, we will convert that for a response time to you. We will take our variables. We know what our oven was at and what our ambient temperature, our oven flow, we know all those variables, so we can actually convert that. Okay, if it needs to be 50, this sprinkler would have to go off at this time. We make that conversion for you. But that's how everything's written, and you'll see it is in an RTI terms. And all that, again, is just, okay, we got to somehow account for all these variables, and there's this equation. You don't need to know this equation. We do the conversion for you. We tell you, okay, here was your time. Here's what it had to go off with our variables in this equation. So those are my requirements. I do like to point out, and it is something people bring up, that, well, my sprinkler in the field shouldn't be expected to perform the same as a brand new sprinkler, and it's not. These requirements are already allowing some degradation from the new sprinkler or the listing process. So UL 199, I'll reference them again. There are other listing standards out there, but For this example, I'll list 199. So Underwriter's Laboratory, if they're going to approve an ESFR sprinkler, they actually have to have it go off at 36 or less RTI. All right, so we've already allowed some degradation for a field sprinkler. Same thing with fast response. 199, if it was brand new, it's expected to have one less than 50. So when people come to me and, well, barely failed, you know, can't you allow a little room for degradation, or why doesn't NFPA allow some room? They already do. It's already accounted for in there. Standard response being that it's already 350, there is no, they don't allow any more than that. That's already getting pretty high up there. To be honest with you, most standard response sprinklers are well below that. There's a lot of room for it to go up. So that's the sensitivity part of it. That was the release mech, either the bulb, the soldered mechanism, pellets. That's what we're evaluating, but that's not the whole story. The laboratory, we're also going to evaluate, as NFPA puts it, the functionality. And then they clarify, well, that has to be, the waterway has to fully clear with 7 PSI. All right, so keep that in mind. Again, 7 is very low. Why 7? That's the minimum, I believe, the minimum any system can be used at. When they test it now, I'll get into it again, people come to me and go, well, my system at static, you know, it's just sitting there. It's not, you know, I don't have one sprinkler go off yet. It's well above 7. Why don't you test it at my pressure? Well, one, liability, NFPA is saying, well, we're going to test it at the minimum anyone could ever use it. If for some reason the pressure dropped or I have sprinklers go off, pressure drops, we're going to test it at 7. The other argument brought up is, well, we should allow some degradation for field sprinklers. Again, we already are. Your brand new sprinkler, when it was UL listed, if it was, it should be, it was tested to be 4 plus or minus 1, so anywhere from 3 to 5 PSI. They had that sprinkler go off with that low of pressure. So NFPA has, again, already allowed a little bit of room for degradation. We've allowed up to 7. So that is the pressure that is put on the water seal, and that's what we want to see the water seal fully clear. If it does not, then it doesn't pass. All right. Now, the functionality I always like to bring up, so we're evaluating with the release mechanism, sensitivity, functionality, making sure that water seal fully clears off there. There's a lot, that functionality, I don't like that term necessarily because there's a lot with the sprinkler that's functionality. The water distribution pattern, for one, right? That's how a sprinkler is going to function. It's going to get my water where I need it to go. That's not something we evaluate as part of the field service test. Again, we've talked about that before. That's why we consider a sidewall and a pendant version of a sprinkler where everything else is the same. For testing purposes, that's the same. We're not doing any distribution testing, any corrosion testing, any loading testing. You know, we're not doing any of that extra testing that you would get when it was listed. All right. So why don't I do everything under the sun? Why don't I do the full UL 199 recertification? And again, that all just comes down to money. Doing something like that would be unreasonable. We're talking thousands and thousands of dollars. That, okay, the whole point of offering testing, and if NFPA wants to offer testing as in lieu of replacement, is to make it more economical. So to make them go through all the testing, we just can't do that. That's with all of our services here at Dine for periodical purposes. They pick a few key benchmarks, and that's what we check. So that's what we're checking here at the laboratory. So that was it. That was the test. You get a report from us. If it passed, you can keep going. 5 or 10 years, you have to test them again until they fail. If you get a failure, based on what you represented, you're going to have to replace whatever that represented. So I get a lot of questions too. I've done the math, and it's pretty close, you know, where they're like, okay, I'm kind of on the edge. Should I just replace or should I test? And the one piece of information they need beyond the number of sprinklers, the testing cost, how often they have to test is, well, what's the chances my sprinkler passes? So a little bit of slide here, just to talk about the failure rates we've seen as of March. So from all time since we started up until a couple days ago when I threw these numbers in there. Overall, every sprinkler we've gotten through the laboratory, 6.8% of them have failed. Now that number, though, is skewed a little bit when I factor in O-rings. I talked about the O-ring recalls, that being a design that is a known issue. Over 50% of the sprinklers that have featured the O-ring, which is actually shown on the picture here, the one on the left, the O-ring, they have failed. And I will tell everyone, if they have O-ring sprinklers, don't even bother testing them, just replace them. That failure rate is extremely high. If I have to send in 4 and 50% of them on average are failing, the chances of you getting at least one failure is very, very high. All right, so let's just replace those O-rings. Now, if I factor those out, if I take out every sprinkler that I have and I just pull out all the O-rings and now I look at the data, well, now I'm down to 3.3% failure. all right? And take that with a grain of salt. Obviously, you've seen some pictures before. When I went through some pictures, that includes, you know, pictures that look like this. Sprinklers people have sent us that clearly should have been replaced, but they didn't. They sent them in, and we tested them, and so that includes some of that. So just be aware. Obviously, okay, I'm saying 3.3%. It really depends on what your environment is. What does the sprinkler look like? Is there some corrosion building up on it, some loading? Got some paint on there. But on average, that's what we're seeing, 3.3%. That's some useful information if you're trying to consider, is it worth testing my 4, or should I just replace all of them? Breaking it down a little bit further too, and this gets into our intervals of testing I talked about before. So standard response sprinklers, those we were going to test after 50 years or replace, test to replace. We're at 3.9% for all standard response sprinklers. For fast response, again, we're starting to see these after 20 years old, only 2.6. That makes sense though, because it's only 20 years old. Up here, these have been out there for 50 years. So this is why this number here, the 2.6, the NFPA is considering, okay, maybe we're getting enough data now to say, okay, maybe we can go to 25 years. Maybe in the future we can go to 30. I mean, wouldn't it be nice if it was all just, okay, 50 years for every sprinkler, right? Just one number. We'll see. We'll have to see the failure data. Dry sprinklers, again, now we've seen a lot. My current standard says 15 years. Up until that, it was always every 10 years. So after 10 years old, my failure rate, again, all this information down here is without the O-rings factored in. Keep that in mind. I pulled those out. Only 1.9%. And this is why, okay, NFPA saw 1.9 and goes, you know what? We can wait. We can go to 15 years with this. And if that number continues to be low, we can go to 20 years. Okay? So that's kind of why we're seeing the intervals we do. Again, the fast response, new technology, dry for a period had a really high failure rate. We got to get those tested sooner. But as this data trends in the direction that's going, where, hey, we can probably extend it longer. We'll see how that goes. But already, from probably your edition to your states on, I'm not aware of any that are on the 2020 edition, but the 2020 has already moved the dry sprinkler to 15. So, and if anyone's curious too, I talked about before corrosion being the #1 cause of failure here at Dine, and typically it is the water seal. 5.8% of that 5.8% of them was due to the water seal being stuck, which is more common at 4.2 than the release mechanism either being delayed or not going off. So a lot of times we're having that corrosion buildup either externally or internally and keeping that water seal stuck. It's not going off at 7 psi. But we still see quite a few either delayed, it's not going off in time, it's not having an RTI below what it should, or not releasing at all. We still see that from time to time. So again, what's shown on screen is just that O-ring. You can see the rubber O-ring here. You've probably heard the slogan, if it's flat, send it back. Again, this here is always a dry sprinkler, but this would be the O-ring on a dry sprinkler. You can see the cap here, this piece is butted up right against the frame, and that would be in any type of sprinkler you see. Commonly, instead of an O-ring, you either have a copper gasket, kind of a little piece between it, or you have a Bellevue spring, a washer, it looks like, holding that cap away from the frame so it can't corrode together. But that is the failure rates as of March, and that was my presentation. We'll go through some questions here. If you got them, put them in the chat or the Q&A section. Looks like we may have got some already. I'm just going to scan through them.
At the bottom, that's the question.
A harsh environment, what constitutes a harsh environment? Yeah, that is a loaded question. That's a great question. Again, I mentioned it briefly before. I'm going to look at my 2020 edition, but if you have previous editions, this was in there too. In the annex, so with all these, the enforceable code at the beginning, and then there's annex. Annex A is always explanatory material, so it's not necessarily enforceable. We're talking it's worded like should instead of shall, where the code would be shall. But you can go back there for that section where it talks about harsh environments, and there's a part that actually gives a lot of examples. Again, we have paper mills, packing houses, tanneries, alkali plants. So when I'm reading through a lot of these are going to have chemical vapors, something that's going to react with my metal, my material. You may not know the metal. You can look at your data sheet and try to figure it out. But I always tell people it is still a loaded question, even with these examples, and it's not all-inclusive with these. Is to contact the manufacturer. Hey, I have this sprinkler. What's it made of? Is it going to react with my hazard? You know, if you're in that tanning plant, what chemical are you using? They're going to ask you that. And what's my vapors? So I would always default to them. You know, they know the material that was used to make it. They should know, okay, this can be considered harsh. but even, you know, like the debate at the committee too, it's hard to define, right? Because even water is corrosive. I have water, oxygen, and metal. I have corrosion. So how much water is too much? I mean, that's not ever going to be defined in here. That's up for debate. Obviously, you could play a conservative, and if you're on the edge, okay, just consider a harsh environment and either replace or test. Note everything I talked about today is part of the routine testing. So as defined in those intervals, there's nothing to say you can't, if you're concerned, you know, okay, I'm due for replacement or testing if you don't want to replace 50 years, but I'm 35 years in, it's not due for testing, but I'm a little concerned. You certainly can take even just one sprinkler. There's nothing governing how many you have to take down for what they call non-routine testing, which is also explained in the annex. If you have one random one, you're like, you know what, that looks, I got a couple that look like that. I'm going to take one down, send it to a lab, and see, is that corrosion detrimental or is that loading detrimental? If you don't want to make that judgment call, send it to a lab, send it to us, and we'll make that quantitative analysis so you have some backing, some proof. All right, and again, that non-routine testing, that 4 or 1% rule I said, you don't have to follow that, right? We're outside the requirement to fulfill there. You can certainly take one down. I'm just curious, again, you're gonna have to replace that one. In the testing, you know, you're gonna have to pay for that one sprinkler, but we'll still test it. We don't have any minimum. Again, we'll test whatever you send us. So, but that is a harsh environment. It's an often question. Again, there are examples in there, but I'll always default to, okay, well, go to the manufacturer, here's my sprinkler, and here's the chemical in the area, here's what vapors it could put out. Is this going to corrode with the metal? Or keep an eye on it. If you're in an area and maybe someone's decided this isn't a harsh environment, but you go back in 5 years and holy cow, all of these are corroded. You're probably in a harsh environment, you should probably have that discussion with that owner. You really need to step this up every 5 years. Look at all this corrosion. And if they're, wow, I think it's fine. Well, let's take one down. We're not in the window yet, but let's take one down. Let's get some data. Let's be sure. So, did you, Jenny, see any other? Oh, I see some here.
There's a few more.
How long is a past test for a dry pendant good for? So a dry sprinkler pendant, again, the orientation not important to the testing here, but a dry sprinkler, again, we're at every 10 years is the interval to test there. So if you're following 2020, after 15 years, you're going to test it, but up until then, after 10 years, you take it down, you send it to us. That's what you've chosen to do instead of replace. And we go, yep, hey, this dry sprinkler's still going. It probably doesn't have an O-ring seal. It's still good. Okay, how long can I go? 10 years. Unless you're in a harsh environment, then we're going to see that every 5 years. So 10 more years, you're going to have to take another 4 down, or 1%, whichever's greater. And then, okay, if it passes again, you can go 10. You can keep going for a very long time. But that's where the cost comes in, right? It's my cost to replace everything versus my cost to test for, but it's also keep in mind, well, if they pass, I'm going to have to do that again in 10 years. And again, with dry sprinklers, it gets to be, you know, the cost of replacement and testing is so, or the time interval between replacement and testing is so close. So if I replace, yeah, I can go 15 years, but I test, I go 10. That's pretty close. But something like standard sprinklers where it's after 50 years, and then if I replace, I can go another 50 with my new sprinklers that I put in, or if I tested and they were good, I'm going to do that every 10. But for when you have a large sample area, it's certainly worth it where the cost to test for, even every 10 years for 50, 60, 70 years, it's still much lower than replacement in a lot of cases. But so how long is a passing test good for? It depends on your type. You asked specifically dry pendants. It would be 5 years if you're in a harsh environment or 10 years if you are not. When did they stop using O-rings on dry pendants? I've been saying over 15 years. I don't know, it was in the early 2000s, I believe. So now we're closer to 20 years. You know, and that is kind of the next edition, I guess I can tell you there. In draft 2, if you pull it up, and anyone can pull this up for free, nfpa.org, next edition. The draft 2 comments are open. You can see right in there they've actually moved it to 20 years. So that's why I'm guessing too, is it's been over 20 years since we've had a O-ring dry pendant listed. Stop using, I guess the way you've worded it is a difference. There's still some out there. We still see some O-rings come through, and we're slowly weeding through them because again, that failure rate, the chances are they fail is going to happen. We're going to have it, but yeah, there are still some out there that either haven't been tested, haven't been caught, but they slowly are getting out of there. So stop using. There's still some people. It was a voluntary recall. Still some out there, but listed, like you could go purchase being UL listed. It's been probably over 20 years now. Corrosion from salt air on the fire sprinkler head failed within a year from installation. Is this typical? It can be. I mean, depends, depending on, so, man, I got corrosion, it failed within a year. That's a good candidate to talk to the manufacturer. What solutions do you have? They may not have a solution for you. That may be the best. You may have to be on a yearly replacement. You're in such an extreme condition. But if you're talking, maybe you used this sprinkler, well, hey, it's going to cost you a premium, but we got a stainless steel version, all right? And that'll let you go 5 years. You'd have to do that at cost analysis. Okay, I have to pay more per sprinkler, but instead of every year, I'm going to go every 5 years. But I have seen it before where the manufacturer, either some environments that, look, this is the best we can do, even stainless steel, wax coated, you're still just going to have to replace sooner. I mean, these are minimums we're talking about in the standard, but depending on what you got going on, I would have a discussion with the manufacturer. Look, these are failing just after a year. Here's my current design. What do you got? And they may have a solution for you. You may not like the price, but it would be something to factor in. So is it typical? I would really have to know, okay, well, I'd have to really know the environment, more details on that. So how often are we supposed to test ESFR sprinklers? So again, ESFR is early suppression, fast response. That's what ESFR stands for. Fast response is in there. So that's going to fall under a definition currently for fast response, which was every 20 years. So I say currently, again, you can go to the next edition. The draft 2 in there does break out ESFR. They keep it at 20, but they're considering moving all other fast responses to 25. So again, those intervals are starting to get extended just from the failure rates. The current designs being quite good now that we've gotten rid of the O-ring debacle. So that is how often am I supposed to test ESFR? Right, 20. Both editions now and in the future is looking like 20. Do you identify O-ring sprinklers? On our report, we identify several attributes, and the water seal design is one of them. So it would say O-ring or copper gasket or Bellevue washer. So yes, they would be identified, and typically, if you have a failure, we're going to contact you just to give you a heads up. Hey, we just sent this report, and a lot of times it'll be above the results or with the results, just to let you know they failed. We notice these are O-ring. This is pretty common. They've all failed. The release mechanism was fine, but the water seal stuck, and that's pretty common for O-ring. To be clear, we don't identify all recalled products. That is outside the scope of what we do. NFSA, I believe, may have started trying to collect the database of all recalled products, but unfortunately that information is spread everywhere right now. So that's not something we clearly identify. That is up to the building owner or designated representative to identify recalled components, devices, if you will. But O-ring part itself, yes, our report identifies the water seal and the release mech, because that's what we test. And we need data on, okay, how many O-rings fail, how many. So that is something that appears on there, just like the model, the year, temperature, is it a dry sprinkler or not, anything related to the testing we're doing that can easily be identified visually. We also do provide pictures, I guess plug us a little bit there too, both before testing and after. So when you get your results, there's a link where you can click and see, oh yeah, we get it from different angles. This was the picture we got, we tested it, and then here was the picture through the waterway, so you can see if it fully cleared. How quickly do I get results? That's so standard turnaround, 5 business days or less. We do offer rush testing, which is going to be within 1 business day, but it's going to come with an added fee. So, do you see any more questions, Jenny?
I don't. There were a few people. Let me just turn my camera back on.
Yeah, go ahead.
There were a few people that had some issues with seeing all parts of the website, maybe the pictures or the video. I just want to tell everybody that the video recording will be available later today or tomorrow, and I'll make sure everybody gets a link to that if you'd like to rewatch it or share it with your colleagues. That'll be available. Anything else coming through?
I don't see on my end, no. Okay. Let me put on screen real quick before we go. If I didn't answer your question or you missed me or something here, you can certainly reach out. There's my phone number and my extension, and as well as my email. If you got any questions, feel free to reach out.
Great. Well, thank you everyone for being here. We really appreciate you spending an hour or so with us. We will be sending you a survey and appreciate your feedback, including any future topics you'd like us to cover. Like I just said, we will also have a link to a recording of our webinar where we publish on our YouTube channel. Our next webinar is scheduled for April 21st. It's going to be on the Portable Fire Extinguisher Dry Chemical Research Study. The link to register will also be in our follow-up email communications. And as always, watch the DINE website, our LinkedIn or Facebook pages, or our monthly newsletter for updates. And thanks again for joining us today, and we'll see you next time.